Mode of grouped data. In this module, we will introduce mode of grouped data. We know that a mode is that value among the observations which occurs most often. That is, the value of the observation having the maximum frequency. This is how we find the mode of ungrouped data. Here, we shall discuss ways of obtaining a mode of grouped data. It is possible that more than one value may have the same maximum frequency. In such situations, the data is said to be multimodal. Though grouped data can also be multimodal, we shall restrict ourselves to problems having a single mode only. Let us take an example of ungrouped data. Example: the wickets taken by a bowler in 10 cricket matches are as follows: 2, 6, 4, 5, 0, 2, 1, 3, 2, 3. Find the mode of the data. Solution. Let us form the frequency distribution table of the given data. We can see that 2 is the number of wickets taken by the bowler in the maximum number, that is 3 of the matches. So the mode of this data is 2. In a grouped frequency distribution, it is not possible to determine the mode by looking at the frequencies. Here we can only locate a class with the maximum frequency called the modal class. The mode is a value inside the modal class and is given by the formula mode is equal to L plus F1 minus F0 upon 2F1 minus F0 minus F2 into H. Here, L is equal to lower limit of the modal class, H is equal to size of the class interval, assuming all class sizes to be equal, F1 is equal to frequency of the modal class, F0 is equal to frequency of the class preceding the modal class, F2 is equal to frequency of the class succeeding the modal class. Let us consider some examples. Example: a survey conducted on 20 households in a locality by a group of students resulted in the following frequency table for the number of family members in a household. Find the mode of this data. Solution. Here, the maximum class frequency is 8 and the class corresponding to this frequency is 3 to 5. So the modal class is 3 to 5. Now, modal class is equal to 3 to 5. Lower limit L of modal class is equal to 3. Class size H is equal to 2. Frequency F1 of the modal class is equal to 8. Frequency F0 of class preceding the modal class is 7. Frequency F2 of class succeeding the modal class is 2. Now, let us substitute these values in the formula mode is equal to L plus F1 minus F0 upon 2F1 minus F0 minus F2 into H. We have 3 plus 8 minus 7 upon 2 into 8 minus 7 minus 2 into 2, which is equal to 3 plus 2 by 7 is equal to 3.286. Example: the marks distribution of 30 students in a mathematics examination is given in this table. Find the mode of this data if the mean of the data is 62. Since the maximum number of students, that is 7, have got marks in the interval 40 to 55, the model class is 40 to 55. Therefore, the lower limit L of the model class is equal to 40. The class size H is equal to 55 minus 40 is equal to 15. The frequency F1 of the model class is equal to 7. The frequency F0 of the class preceding the model class is equal to 3. The frequency F2 of the class succeeding the model class is equal to 6. Using the formula of mode is equal to L plus F1 minus F0 upon 2F1 minus F0 minus F2 into H, we get 40 plus 7 minus 3 upon 14 minus 3 minus 6 into 15 is equal to 52. Here we can see the mode is less than the mean. But for some other problems, it may be equal or more than the mean also. It depends upon the demand of the situation whether we are interested in finding the average marks obtained by the students or the average of the marks obtained by most of the students. In the first situation, the mean is required, and in the second situation, the mode is required.